A huge thanks to Brian for sponsoring this video. Quick announcement, big announcement. My mobile game WAC released on April 1st. Make sure to check it out and support the channel this way. It's for completely free, so you don't need to pay anything. So yeah, make sure to check it out. Link down in the description. Download it and yeah, just have a bit of puzzle fun with WAC. Today, a quick one, or rather interesting one, from the 1999 Czech and Slovak, they are the neighbors to Germany, so at least the Czech Republic, mathematical Olympiad regionals. Namely, we have a mapping given, f goes from the open interval 1 to infinity to the real numbers, and we need to find all the functions f satisfying this functional equation right here, f of x minus f of y is equal to y minus x times f of xy. Yeah, and that's what we are going to do today. Functional equations are always a lot of fun, and I hope you are going to enjoy what you are going to see today. By the way, if you're not yet familiar with functional equations or functions in general, mappings and all this crazy stuff in calculus, why not make sure to check out the contents of today's sponsor Brilliant. Link down in the description, more information at the end of the video. So get prepared and then keep watching the video for the solution. And now we are going to dive right in. So when it comes to functional equations, the first thing I do is just I plug a bunch of numbers in. I start to parameterize, okay? That's mostly the only way you can get something like this done. And if you take a look at the interval, it's the real numbers where x and y cannot be equal to 1. So we need things greater than 1. And when I first did this, I just plugged in natural numbers one after another, just because I don't want to deal with fractions or the like at the moment. We're going to plug in real numbers. So at first I just kept x how it was. We're going to call it t, just for the sake of parameterization. And then I plugged in the successor of 1, 2 into y. So what happens if we plug in basically the tuple, you could say, to the point t, comma 2. Well, then what we're going to get is that f of t minus f of 2 is equal to 2 minus t times f of 2t. Okay, thus far that's good. This is the first equation we now got. Why not keep parameterizing here a tiny little bit? So next thing I did, I plugged in the number 3, but this didn't lead anywhere. So I took the next even number, because 4 is 2 times 2. So why not do that? Why not plug in the tuple t, comma 4? Well, then we are going to get the same thing that we have up here, just with a 4 instead of a 2. So f of t minus f of 4 is equal to 4 minus t times f of 4t. This is not bad, because if we now were to subtract those two from one another in some kind of way, then we're going to get rid of the f of t at least. So let's subtract these really quick. Let's just subtract it really doesn't matter which way around, you can always multiply by -1. Let's subtract the second one from the first one, giving us, okay, f of t is going to cancel out. Then we are going to have f of 4 minus f of 2 is equal to, okay, now we are going to get, in this case we're going to get a negative sign here, so meaning we are going to get 2 minus t times f of 2t, and then minus 4 minus t times f of 4t. Okay, now we got a new equation, but things are still bothering me here. We can't really say what f of 4 is and what f of 2 is. We have no idea if this is, for example, a homogeneous mapping in some kind of way, or linear mapping, such that we can turn the f of 4 into f of 2 times f of 2, for example. We have no more information about the mapping given at hand. So why not try to parameterize it a tiny little bit more, and then let's see if we can substitute something in or eliminate. Now, this is very easy to do. So we could, for example, instead of t, this time take 2t, for example, and then see what we are going to get. If we were to plug in 2t, this is a great idea, then we get 2t times 2, which is 4t once again, so we are going to get another factor of 4 times f of 4t. And also if we got f of 2t, maybe we can eliminate something when it comes to this part right here, f of 2t. So why not plug in the tuple or the point 2t, comma 2. This is yet another parameterization. For t, by the way, all the other conditions apply, namely that it needs to be strictly greater than 1 and up until infinity in the interval. So what we're going to get is f of 2t and then minus f of 2. Okay, is hence equal to, this is going to give us, okay, if we plug in 2t into here, we are going to get 2 minus 2t times, and as mentioned before, f of 4t. Okay, now we are going to play around with this expression a tiny little bit. What we could do, for example, is we could solve this whole equation for f of 2t, and then we could substitute it into here. Substituting, for example, for f of 4t would also work, but then we would end up with something fractional, because we would need to divide both sides by 2 minus 2t. Maybe that's a mess, we don't know, so we are going to go the safe route, and we are going to solve everything for f of 2t. Giving us overall here plus, and this comes in equals to. And by plugging the f of 2t into here, what we are going to get is this huge new expression, namely that f of 4 minus f of 2 is hence equal to. Now we are going to get 2 minus t times, okay, at first f of 2. And next we are going to get plus 2 minus t, and then we are going to get times this factor, so 2 minus 2t times f of 4t. And other than that, we still have negative 4 minus t f of 4t. And this is not even half bad if you take a look at that, because now we only have one reparameterization left in our argument, namely on this f of 4t. So why not take common factors, for example, and then let's see what we can still build up. So what we could do is, for example, we could add the f of 2 on both sides, and then we could start factoring stuff out. So adding this on both sides gives us this. And if we were to factor this out, then we are going to get that f of 4 is hence equal to. Now, if we were to factor out the f of 2, we are going to get 1 plus 2, okay, using the distributive law. So this gives us the successor of 2, which is 3, minus t. Okay, first part done. So we got rid of this. And other than that, what is 2 minus t times 2 minus 2t? Okay, let us just write everything out and see what we are going to get. So 2 times 2 is going to give us 4, and then we are going to get minus 4t. Other than that, we get negative 2t, and then we are going to get plus 2t squared. Meaning overall here, we are going to get, okay, negative 4t minus 2t is going to give us 4 minus 6t plus 2t squared. Okay, thus far that's good. Meaning what we can now do is we can factor out the f of 4t, so plus f of 4t times. And now if we were to bring those two together, we are going to get 4 minus 4. Hey, this is going to cancel out. This is very nice. So our plan is working out at least. In some kind of way, then we are going to get negative, and negative is positive, so negative 6t plus t is going to give us negative 5t. I'm going to put it here just because of negative sign. Let's keep it nice and ordered. And other than that, we still have plus 2t squared. Okay, this ain't even half bad. If you take a closer look, we got a common factor of t here, which we can also factor out. And why not at this point try to solve for something, or maybe substitute something new in? And for this, I'm going to factor out the t, just as mentioned previously. And the best thing would be to just get an expression in terms of a constant. For example, some constant is going to be equal to some other number, and then we can plug this new number in. So for example, if we were to solve for f of 4, then that would be very great. Then we could plug the f of 4 into one of the equations up here, for example, and then we could start solving further for f of t overall. So yeah, what would be the best way to get rid of all the parameterizations here, and then we could plug numbers in, which would turn out nicely? Well, we could very nicely eliminate this whole part by, for example, if we set t equal to 0, then this also gives us an expression in some kind of way that we could plug in. But t cannot be equal to 0. This is a problem. So we can just plug in t equals to 0 because of the interval that has been given by the problem. So we can just simply eliminate this part by setting this equal to 0. But we could, for example, say 2t minus 5 must be equal to 0. If this is the case, and if this holds for our interval, then we would be good. Then we could solve for one of the constants here. So when is 2t minus 5 equal to 0? Adding 5 on both sides and dividing both sides by 2 because it's not equal to 0 gives us t being equal to 5 over 2. And this obviously is in our interval. This is some kind of parametrization or a value that we could plug in for our t, which is still in our interval. So if we were to plug in 5 over 2 into our t's here, then this whole part is going to vanish in the process, and we are going to be left with f of 4 is equal to f of 2 times 3 minus 5 over 2. So let's do this real quick. So if we plug this in, then f of 4 is equal to f of 2 times 3 minus 5 over 2. 3 minus 5 over 2 expanding, this is going to give us 6 over 2 minus 5 over 2 is 1/2. Hey, this is not even half bad, obviously. So f of 4 is hence equal to f over 2 f of 2 divided by 2. So we got a value for f of 4. And now we can start plugging this into any of the equations that we got before once again, and then we can see if we can solve this whole thing in some kind of way, or if we can reduce it in some kind of way to a lower form, you could say. And we could plug this into one of these, or we could just plug it into here once again. But if we were to plug it into here, this is only under the condition that t is not equal to 5 over 2 in this case. So let's go with this for now, but we need to see at the end if the solution that we get after solving for t or f of t or etc. is still valid for t being equal to 5 over 2 at the very end. So why not plug the new value for f of 4 into here, and then we are going to see what we are going to get. So let me put this chalkboard here, and then I can start writing once again, just for comparing. Meaning f of 4 is equal to, so we know that f of 4 is equal to f of 2 over 2, and this is equal to, okay, so we get f of 2 times 3 minus t, and then we are going to get plus f of 4t times 2t minus 5 times t. This right here is our new equation. And now we can once again go ahead and start solving for one part. So we got rid of this part right here because this is equal to f of 2 over 2 by the equivalence relation. Meaning what we can do is we can, for example, factor out the f of 2 here. Meaning we can subtract f of 2 on both sides, giving us a new equation here, which we are going to deal with now. And if we were to factor it out, we are going to get f of 2 and then times. So we are going to get 1/2 minus, and then we're, okay, with the negative sign here, we are going to get negative 3 plus t. So if we have 1/2 minus 3, this is 1/2 minus 6 over 2, this is negative 5 over 2. So giving us overall, if we were to, no, we don't need to factor anything out. I'm just going to make use of the abelian property of the real numbers to just interchange this to give it a better form. Then we are going to get that f of 2 is hence nothing other than, or f of 2 times, it's f of 2 times, I'm terribly sorry, I'm being confused here, so much algebra, f of 2 times, and then we are going to get, as mentioned before, t minus 5 over 2. And this is obviously equal to f of 4t times 2t minus 5 times t. Now, this is rather curious, don't you agree? Maybe you don't see it right now, but what happens if we were to factor out the 1/2 here? Okay, this is our new equation that we're going to deal with. Factoring out the 1/2 on this part is going to give us that f of 2 over 2 times, okay, factoring out the 1/2, tracking a 2 in the front of our t minus 5 is equal to f of 4t times 2t minus 5 times t. Oh, this is curious. Hey, this works out. Since t is not equal to 5 over 2, this is the restriction that we set. By plugging it into this new equation right here, we can divide both sides by it. And if we were to divide both sides by t, it can't be equal to 0 because of the restriction on the interval. We are going to get that f of 4t is equal to f of 2 divided by 2t. Hey, we got an expression for f of 4t that we could now plug into one of the original equations, for example. You could also plug it into this equation right here, for example, once again, but it does make more sense in the context to plug it into here, just because we are going to have f of t single-handedly here, and since we solve for f of 4t, this is the best way we could do it. If we were to plug it into here, that would be bullshit, at least because we got f of 2t here, giving us not a good expression for f of t. Or we could introduce another parameterization. Really doesn't matter. We could just introduce a new parameterization being equal to x divided by 2 being equal to t. But never mind. We can just plug it into here. It's an equivalent formulation, giving us overall that f of t is hence equal to, okay, we got f of 4 in our case, and then we are going to get plus 4 minus t, and we also know what f of 4t is. F of 4t is f of 2 divided by 2t. And now what we can do is we can just start solving once again, because we also know what f of 4 is. F of 4 is something that we have found out before. This is the same as f of 2 over 2, giving us that this is f of 2 over 2 plus, and now we can just multiply everything out. Now 4 and 2 is going to cancel out, giving us 2 times f of 2 divided by t, and other than that we are going to get negative t, and t is going to cancel out, negative f of 2 over 2. Hey, this is good. This is very good. And that is going to cancel out, giving us a final expression for f of t being equal to 2 times f of 2 divided by t. And if we were to evaluate a function at a certain spot, x, this is just a constant. Constant multiplied by yet another constant is going to give us a constant, meaning the final form of f of x for our question right here, the solution basically, is some constant kappa out of the real numbers divided by t. And obviously this also holds for 5 over 2. Okay, if we impose the restriction once again, no, it must be x here, I'm terribly sorry, not t, I'm being stupid. If we plug 5 over 2 into here, it obviously works out in our case. Yeah, this is not some kind of poll or the like, it works out. And this exercise was a lot of fun, and I hope you were able to follow everything I said here. And if you're interested in more problems of that kind, functional equations, analysis, calculus in general, then why not make sure to check out the contents of today's sponsor Brilliant, who are kind enough to sponsor yet another video here on this channel. Man, I'm doing quite a lot of contest mathematics on the channel here in the last time, but it's just what I do at the moment. I don't do higher mathematics anymore at the moment because I stopped studying at university, obviously, but I still try to still keep my brain active in terms of mathematics with these exercises, and they are a lot of fun. But many people don't know where to start or where they could learn the skills to also participate in things like MIT Integration Bee, Putnam or whatever, and this is where Brilliant comes in. Brilliant is your platform for nearly 70 interactive courses in all topics STEM, be it mathematics that we did today, physics, computer sciences, chemistry, whatever it is you want to learn today. Brilliant definitely got something on the website that you could benefit from. And their course concept is, how should I put it, very unique in the sense that I have not seen such an interactive learning experience anywhere else on the internet before. How a course basically works is you're going to start off with a simple topic, for example contest mathematics. They're going to give you a little introduction into the topics, what will be used, prime factorizations and the like. And then you are going to work through their courses, all underlined with interactive graphics that you can play around with to get a better understanding for the topic at hand. And the courses are going to get gradually harder. It's just the way of learning that you go through school too. You're going to start off with the basics, and all of the other things that come after that rely on these basics. And this is what Brilliant also does. It's going to get harder, you're going to get a better understanding for the things that you are learning right now, and you're going to start to apply it to different types of mathematics or maybe also different branches of STEM. which is pretty great. Mathematics has so many applications in other STEM fields like physics especially, chemistry and all the other things, also in philosophy. And Brilliant always makes sure that you are going to apply the things and the basics that you have learned also to their other courses in some kind of way. Just go over to their differential equation courses and then over to their Newtonian mechanics. And you're going to understand what I mean immediately. Little hint, derivatives. So if this feels like something for you, if you feel like this could benefit your STEM career in any kind of way, then why not make sure to check out the link at the top of the description, brilliant.org/ramblemeths. With it you are going to get free access to a big portion of Brilliant already, but more importantly, the first 200 people to actually make use of the link get 20% of an annual premium subscription, which is a freaking great deal considering how much content they actually have available on their website already and how much they are adding on a regular basis. So definitely make sure to check it out and support the channel this way. And what else can I say? WAC. Don't forget to also check out stemmerch.eu for handcrafted merch. And up until the video next, guys, wishing you a day flammable. Ciao. What is ciao backwards? Awish. Awish.